We walked on the moon 45 years ago, so it would only be reasonable that a human with sufficient nutrient and an active schedule can live in outer space for more than 2 years.
Humans have long been dazzled by Mars since they first saw it. Today, its human exploration seems to be the next frontier. A far frontier, as the longest that any human has spent away from home is just 440 days. Its consistency on Earth. We take the force of gravity for granted, but variations in the pull of gravity can take a serious toll on the human body. You can never fully escape the effects of gravity on your body. Objects orbiting the Earth still feel a relatively large pull from the Earth's gravitational field.
However, for a shuttle traveling to Mars, the Earth's force of gravity decreases to nearly negligible amounts.
Whenever leaving Earth, astronauts often coin the phrase of feeling weightless, or experiencing microgravity.
What happens to gravity when people and objects go into orbit? And how do you get this microgravity? Regardless of what you are doing while watching this video, you are directly affected by the action at a distance force of gravity. Although you may think that you can feel gravity at this instant, it is in fact the contact you have felt with other objects as a result of gravity that gives you the feeling of weight. Today, the scales used to measure one's weight abide by Newton's third law. An applied force will be met by a force of equal magnitude and opposite direction. Assuming that you are on a level plane, the scale only measures the normal force that the scale is applying on you. As you are not sinking into the scale, its normal force is equal in magnitude to the gravitational force acting on you. People in the International Space Station or any other vessel orbiting the Earth are constantly falling as a result of Earth's gravitational force. Both the vessel and the occupants start to undergo freefall at the same time and rate. The vessel and the occupants never meet as the passengers are constantly chasing after a ground which is running away from them. In this cat and mouse game, there is no point at which the person's body and the vessel body come in contact, and therefore no normal force would actually be felt from the vessel walls. This feeling is commonly linked to the term microgravity, which is incorrect as the gravitational force on an object is not even close to zero in the low Earth orbit and that the ISS is in. So you can finally lose all of those pesky pounds. Well, kind of.
What do we know about the effects of microgravity on the muscular and skeletal systems so far? The effects of microgravity are different for everyone. For example, a sumo wrestler's feet need to provide 1,825 newtons of normal force to prevent his 186 kilogram body from cracking his legs. In space, this sumo has no normal force acting on them. As a result of the little force needed to keep the sumo upright, his muscles and bones degenerate. Space weight loss may sound good to a dieter, but this loss will not be done through burning fat. The sumo could expect his muscles to atrophy at a rate of 1.5% a month and his leg bones to weaken 10%. Although you lose muscle and ultimately become skinny, you will be glad to know that your joints and vertebrae separate, curing your backaches and making you about 7 centimeters taller. So you can finally stop cheating when you measure your own height. Is there a way around this problem? Scientists are finding new ways to stop the harmful physiological effects of microgravity. So far, rotation and linear acceleration are the best ideas to mimic the force of gravity on space vessels. Rotation relies on the body's inertia and the centripetal force created by the outside wall of ring-shaped, uniformly rotating ships to simulate the effects of gravity on Earth. For enough force to be felt, the ring would have to be at least 224 meters in radius. Like the idea of an accelerating car, the linear acceleration of a vessel and the inertia of its passengers' bodies would push the vessel's passengers backward into the vessel walls, giving them the sensation of gravity. No matter how you spin in it, you have to appreciate gravity is present in our daily life and keeping our muscles and bones strong, not just bringing you down.